Hello and welcome to episode 2 of the Screeps tutorial series. Today we're going to create a harvester and a worker role. So we have a creep that'll upgrade the controller and a creep that'll keep the spawn full so we can keep new creeps coming out. In episode 3 we're going to go over making the spawn system itself, so we don't need to worry about that. And I'll have both of these lines right here in the description. These will create the creeps we need right now for testing purposes while we are making these roles, and then in episode 3 we'll actually go over implementing these into the spawn system. So let's start off here. We want to spawn the creep that we will be working with first. So go into the first line, the one with harvester as the role right here, and paste that into the console. Press enter. We get a 0 back, which means it was successful, and we can see the creep is spawning right here. So as the name suggests, we're going to start with the harvester, whose goal is to mine energy from the source, take it back to the spawn, and fill up the spawn so we're able to spawn more creeps. So if we can check their memory right here, you can see they have a property called working, which can be true or false, and currently by default it is false. And their role, which is harvester. Okay, so let's jump right in here. First thing we want to do is make a new file. Let's call this harvestermanager.js. And in here we can define the harvest manager class, harvester manager, and we want we want a function here that will run the role. So now let's just add a console log test to make sure we can get this function here running. Actually, what we're gonna do here is just export this whole file. So module.exports equal to this object, and the first property of this object is actually going to be a method. Run the role for the harvester creep, and it's going to be so this right here is an object, and the first property of that object is run role, meaning we can access this by object name dot run role, and we pass it the creep here, and then we have the body here. So let's actually test this right here. Oh, we actually have to go here and import it. So we want to import the harvester manager file and save it into a variable called harvester manager. Then we can do harvester manager dot run role, and we would pass it the creep here, so we don't actually have a creep to pass it right now, but it's not a problem because we save that. Then we go here and we can see that it's running successfully. We'll actually move this up here, it looks nicer. Okay, so now that we have that under control, let's go here, actually take a look what we have. Again, this is an object being exported and now being saved into Harvester Manager. .run roll means we're accessing run roll right here, and the value of that property is a function called run roll. Actually, we don't need that. Maybe we do. Interestingly enough, that still works, so you don't have to name the function twice. So yeah, run roll is just a function right here, takes a creep. Let's actually give it something to do. So we have the creep sitting here, working false. And it's a harvester. So we have run roll running right here. Let's do, we want to run this for every creep. So let's do constant creep in game.creeps. This will so yeah, this will do just like the comment says, run the Harvester Manager for every creep in the game. So let's actually pass it game.creeps and the key creeps, because when we're using the in keyword here, we are getting a key, not the value itself. So actually, more clearly, let's rename this to key, and then move this right here. This will give us the creep. So now, for every time this for loop runs, we get the creep object, and we pass it to Harvester Manager run roll, which again we can find right here. So now, what do we actually want to do with the creep? Let's ensure that it's in the right place. Creep dot memory dot working. Let's just see if it has a working. Creep is not defined. Oh, of course. I changed that and forgot to change it there. And then another small mistake there. So now we should be good to go. Then we can so we want to write when we will switch states first. So let's write an if statement. If so right here I'm getting the sum of everything inside creep carry, because if we look right here, we can go up to creep and go to carry right here, and we actually see this exact line of code in the example here, because each object, there's multiple objects within this carry, so what we actually want to do is sum up all of them. Right now it's just going to be resource energy, so actually I think it would be better if we did creep.carry.energy. Let's make sure that gives us what we want. Before we go further, I always like to check to make sure I'm getting what I expect from variables and functions, so I know I'm not out working with faulty data. 0, so yeah, we know because we can see the creeps carry is 0. Let's also we also want to, sorry, I just realized I never showed you guys the docs where I was. So yeah, creep carry right here, we can see you can grab the sum of everything within it, or you can do this right here and just get the energy. So anyway, moving on, we switch our case when the creep is working, and creep carry capacity, oh no, that's not what we want. We want creep carry equal 0. As a general rule, also, side note, try to always use triple equal. I'll provide links to read more about it, but double equal would also work, but triple equal also ensures that it's the same type as well as the same value. So we want to do creep memory working equal true. Oh, sorry, false. Because it is working and it runs out of energy. So imagine it's filling energy into this right here and it runs out. So the case it's in right now, well, actually not, because it's not working right now. Else if creep memory working, ooh, let's actually do not so if the creep is not working and its carry is at its carry capacity. Now here we do working equal true. Okay, so that's switching states. Run the creep. If we do creep dot memory dot working, so we have a case for if the creep is working, and we have a case for if it's not working. So if the creep is working, what we want to do is find the spawn, and if it's not working, we want to get energy. Not working. So let's start with getting energy from the source, since that's where we are right now. Want to define some spawns. Let's do creep dot We want to look under POS, find closest by path, and then right here we have find my spawns. That's exactly what we needed. So access the room position object and do find my, find closest by path, find my spawns. Oh, and actually, it's a great time to mention, the reason that I have all these pull up is because I have Screeps autocomplete. Let me show you guys how to get that real fast. Type npm install @types/Screeps, and then do npm install @types low-Screeps. I will also be putting those in the description. You need Node.js and npm to download these. If you guys need, I can do a video on that, but you should be able to just look it up and be fine there. So yeah, that turns on autocomplete, which is very useful because now you can do like game, and then you have all the built-in functions to Screeps right here. Game.creeps. So yeah, that also gives you, so if you know what type something is, you have its autocomplete stuff right there. Okay, so now we have the spawns, and we want to try to deposit energy into the spawn. So this is actually just going to give us one spawn because it's find closest. So let's name it constant spawn if creep dot transfer. It wants spawn, and it also, I believe, wants the resource constant. If this is 0, oh no, this is error, not in range, then we want to move to spawn. This is probably the same block of code you would see in the in-game tutorial, or at least similar. And let's go now check where we got all this from. We have creep right here, creep dot transfer, and let's do this so we can see a side by side. Transfer, if I can find it. Yes, it wants the target, which we gave it, spawn. And it also wants the resource type, which, as you can see right here, resource energy is one of those resource types. And actually, this is the block of code we used right here in the example. And if it's return code, because every, I'll actually demonstrate right here. So if we print out the result of this function, we get -6. So what does that mean? Go right here. These are the return codes. -6 is not enough resources. So we're right next to the spawn, but we don't have enough resources to transfer, so the transfer is not going to successfully happen. And I actually just realized we put this in the wrong place, so just take this code and move it up into the main of the if statement. And then, well, now we can, so now we have the spawn code that works. So let's just write that same thing for the sources. Const source, same thing, creep dot room position. Let's find closest by path. Same thing right here. We do find sources active. And then creep dot harvest source, not in range. Then we want to move to the source. So we can actually see this in action now. The creep is not working. It's moving to the source. We can see its energy filling up. Let's speed this up a little, because when it hits 100 energy, it should be marked as working and then start moving to the spawn. There it is. And if we take a look, we can see it's working as true now, and it's on its way to the spawn. And if we spawn the worker creep, which that will be the second line in the description, looks like this, role is worker. We can see two things right here. Number one is that it's spawning the worker. Number two, we can see the harvester deposited his energy once he was able to. So we can see the role here is worker on this guy, but he isn't going to do anything as a worker because he's being run as a harvester. So what we want to do here is create an object . We want a harvester manager and a worker manager object within the properties to be these different files within an object called roles. Then what we are able to do here is do roles dot creep dot memory dot role dot, I believe we called it run role, and give it the creep. Let's make the file titled worker manager.js. What we're going to do right here is copy and paste the code from here, because we only need to change one thing to make this work, but we will go over it again, no worries. So let's save this file. If we go into main right here, I believe this will work. Let's see. No errors, that's always a good thing. Spawn another harvester out so we can see that they deposit. into there. Now, if we go into the worker manager here, all we need to change is right here, where the creep is working. And all we need to change is this variable. This creep.upgrade controller. And the way we find the controller in the room is creep.room.controller. And then we have the creep also move to the controller because we want it to harvest the same, and it's going to have the same cases for switching states. The only difference is once it has its energy, it actually takes it to the controller rather than to the spawn. So creep.upgrade is not a function, so let's actually go into the API here. Creep.upgrade controller. Okay, this is why you always check the docs. So let's go into here. And as we can see, the creep is already moving towards the controller to upgrade it. So we can get more harvesters out, and we can watch this harvester filling the spawn, this harvester upgrading. Everything's working as expected. So what I want to do now is actually take a second to go over what we've done so far this episode and prepare for next episode. So essentially what we have is right off the bat a constant object roles with the property harvester and worker, which are equal to their respective JavaScript files right here, where we export an entire function denoted by these curly braces that wrap the entire thing. And we have a for loop, which we assign a creep every time the loop iterates, and it iterates one time per creep. So the first creep it goes through sets it to the creep using the key in game.creeps, accesses roles, uses the memory to access the key, which would be harvester or worker depending on its role in memory, and calls the run role property on that, which in the case of harvester we have right here, we have these case switching things right here, and then the creep actually running. We tell the creep to stop working when it runs out of energy, and we tell the creep to start working when it's full on energy. When it's working, we find the closest spawn, try to transfer energy, move to if we're not in range. We do the same thing for mining a source. If we go to worker, we see the exact same setup here. The difference is when it's working, instead of going to transfer into the spawn, it upgrades the controller. Alright, that's it for this video. Stay tuned for next video. We're going to build the spawn system itself, and you'll be able to be offline and your creeps will automatically spawn themselves and keep the room going, so you don't have to manually spawn each creep like we did in this video and the last one. Alright, thanks for watching guys, and stay tuned.